Well, welcome back, students. This is the video for section 9.3 on geometric sequences and series. This is the last video for chapter 9, and as soon as we are done with this section, chapter 9, you will be receiving your grade for the standard on sequences and series. Yay! All right. In the last lesson, what we did is we learned about arithmetic sequences and series. Those were the kind that were basically linear. In this chapter, we are going to be learning about geometric sequences and series. So geometric sequences are actually another pretty simple kind, and they look like this. Let me start by giving you an example. So for example, 2, 6, 18, 54, 162, and so on. Now, with the arithmetic sequences, what we had is we had a common difference or a constant amount that we added or subtracted each time. With a geometric sequence, it's very similar in concept, except that instead of adding the same thing each time, you're going to be multiplying the same thing each time. And that is what makes a sequence geometric, that you're adding. In other words, it is exponential. All right. Let's go ahead and derive once again the formula for finding the nth term of a geometric series. And just like last time, it's very easy to do. Let's just derive it. So for example, in this one, the first term is 2. And the second term is 2 times 3, which is 6. And the third term is 2 times 3 times 3. So I'll just call that 3 squared. And the fourth term is 2 times 3 times 3 times 3. And so on. So if I wanted to find the nth term for this particular sequence, I would say it's 2 times 3 to the power of, study this carefully, notice the relationship between the exponent there and the term number. It's one less. And therefore, if I want to find the nth term, it would be 2 times 3 to the n minus 1, which should make sense because to find the fourth term, you start with 2 and then multiply the 2 times 3 times. So in general now, to find the nth term of any geometric sequence, you start with the first term. You multiply it by the constant ratio, which is going to be r, instead of d, which stood for difference. And then we're going to have that to the power of n minus 1. So this is your friendly formula for geometric sequences. All right, let's apply that to a few examples. And this is what it's going to look like in your assignment. Example 1, find the 13th term of 5, 10, 20, 40, 80, 160. So first of all, you should look carefully and decide, okay, is this geometric or arithmetic? Am I adding the same thing each time or am I multiplying? In this one, quite obviously, you're multiplying by 2, you're multiplying by 2, and because you have a common ratio, it's going to be geometric. So of course, we're going to use this formula right here that we just discussed on the previous page. So the 13th term in this particular case would be a sub 13 equals the first term, which is 5, right there, times 2, which is your r, to the n minus 1. Well, if n is 13, the n minus 1 is 12. And you can just put that in a calculator, and you will get that the 13th term is going to be 20,480. These particular sequences can get really big really quickly because you're multiplying. It's exponential growth. All right, here's a second example. In a geometric sequence, each subsequent term is 20% more than the previous term. If the second term is 12, find the 10th term. All right, well, I'm going to kind of leave some blanks here. First term, I don't know. Second term is 12. Third term, I don't know. Fourth term, I don't know. Fifth term, I don't know. But I do know that my common ratio is going to be 1.2. Because if something is increasing by 20%, that means we're multiplying by 1.2. So multiply by 1.2. All right, so just doing some calculations with a calculator if you need to. 12 times 1.2. Well, you don't need a calculator for that one. That's going to be 144th the decimal. Then 14.4 times 1.2, you'll need a calculator there most likely. That's 17.28, and so on. Now, what is the first term? If to get the next term, we have to multiply by 1.2, what do we have to do going backwards? Divide by 1.2. So let's do 12 divided by 1.2 to get the first term, which in this particular case is going to be 10. Okay, so now it wants you to find what? The 10th term. So the 10th term is going to equal the first term times r, which is 1.2, to the 9th power. Now this one we're going to have to kind of round it because it has a lot of decimal places, and it's about 51.6. So there you go. Example 3. Okay, we know the second term is 10 and the fifth term is negative 156 and a quarter. It wants us to find the 10th term. So once again, for those of you who are visual, I'm going to go ahead and kind of write it out like that. There's your second, third, I don't know, fourth, I don't know. Fifth is negative 156.25. The sixth, I don't know. Seventh, I don't know. Eighth, I don't know. Ninth, I don't know. And I don't care. But the 10th, that's what I need to find. I need to find that. Okay. Well, this time I don't know r. So the first thing I'm going to have to do is I'm going to have to find r. So since I don't know, I'm just going to use algebra. I'm just going to say, well, it's r. So it seems to me from this that 10 times r times r times r, in other words, 10 times r cubed, is going to equal negative 156.25. See? 10 times r times r times r equals that, and that's what this equation says. Now dividing both sides by 10, I get r cubed equals negative 15.625. And at this point, if I want to know what r is, just take the cube root. Now, you cannot take the square root of a negative number, but you can take the cube root of a negative number. A negative times a negative times a negative can equal a negative. Well, it does equal a negative. So taking the cube root of that in a calculator, you will get negative 2.5. So what we know is we know that I'm multiplying by negative 2.5. So all I need to do now is times 2.5 times 2.5, excuse me, negative 2.5 times negative 2.5 times negative 2.5 all the way to the 10th term. But I don't feel like doing that, so I'm just going to do this. Let's work our way backwards. So 10 divided by negative 2.5 is negative 4. So my first term is negative 4. So to find the 10th term, I will take the first term, which is negative 4, multiply it by negative 2.5 to the power of 9. And of course, it's going to be positive because this one's a negative, this one's positive. This one's negative, this one's positive. This one's negative, this one's positive. And it's going to be positive. Positive what? I was hoping I had this one in my notes. Oh, I do. It's positive 15,258.8 approximately. So it's a big number, of course, but that's not surprising. Okay, let's see what's on this next page. So the other thing it's going to have you do in this assignment, it's going to have you, just like with the arithmetic sequences, it's going to have you find the sum of some series. For example, I want to find the sum of the first 12 terms of this geometric series. If we were in class, we'd do a fun little proof on this one, but for this year, we're not going to do that because, well, we're trying to keep the time down. So here is the formula to find the sum of a finite geometric series. You take the first term, you multiply it by 1 minus r to the nth power, divided by 1 minus r. Now, if you are curious as to where that comes from, you should look it up. Just look up finite geometric sequences or sum of finite geometric sequences, and you'll see where the formula comes from. It's kind of cool, but it takes about 10 minutes to go through, and we just don't have that time. All right, so let's go ahead and use this to find the sum, and that's what the sigma stands for, of the first 12 terms of this. So first of all, let's make sure you guys understand what this means. So plugging in a 1 here, that'll give me the 0 power. 0.3 to the 0 is 1, so my first term is 4. Then I'm going to plug in 2. And my second term is going to be 1.2. Then I'm going to plug in 3 for the n. And you can just put that in a calculator. and find your third term as 0.36. Then plug in 4 for the n, and you'll find out that your fourth term is 0.108. And anyways, we're going to keep doing this all the way to the 12th term. Now, I don't need to know what the 12th term is necessarily. I just want to know what the sum is. Now, before we go any further, I want you to notice how these numbers are getting smaller and smaller and smaller every time, which means that the sum is going to converge, and there's a big word for you, to a particular number. It's not the sum. If I make this series infinite, the sum's not going to be infinite, because as we go further and further and further in this series, the numbers get smaller and smaller and smaller and smaller and smaller and smaller. We can estimate it. Let's see. 4 plus 1.2 is 5.2. Plus this, it'll be 5.56. This will give me about 5.7-ish. So it's probably not going to ever reach 6 because these numbers are getting smaller and smaller and smaller. Well, let's find out what the first 12 terms are going to equal. Let's use our formula here, which unfortunately I did not have time to derive for you. But the sum of the first 12 terms are going to equal the first term, oops, not plus, times 1 minus r. Now, what is r? What's the number we're multiplying by here each time? There he is, 0.3. And you can check it if you like. 4 times 0.3 is that. 1.2 times 0.3 is that. To the 12th power, divided by 1 minus 0.3. Now, you can just put that whole thing in your calculator. And you will get that the sum of the first 12 terms is about 5.714. And if you recall, that's pretty much what we estimated the first 4 terms were. But that's because the 5th to the 12th term are so small that they really don't do much to the sum. In fact, the first 2 terms together, they're 5.2 already. And if I did the remaining 10 didn't really add much to it. Let's take a look at a series that diverges. Diverges means that it's getting bigger and bigger and bigger and bigger instead of getting smaller and smaller and smaller and smaller. So here's what we need to do. Write with summation notation and then evaluate this guy. Okay, so to write this with summation notation, I'm going to say from n equals 1 to n equals, oh, I don't know. I don't know how many terms there are. Well, let's find out. So 5 times 2 is 10, times 2 is 20, times 2 is 40. So there's going to be an 80. That's your 5th term. Your 6th term. Your 7th term. This is your 8th term. So there are 8 terms in this. And it starts with 5. And it's multiplying times 2 to the n minus 1. So you can check it by plugging in 1 for n. 2 to the 0 is 1. 5 times 1 is 5. So we're good. Now I want to find the sum of the first 8 terms. So this is going to be, using this formula now, a sub 1 is 5 times 1 minus 2 to the 8th. Because my r is now 2, divided by 1 minus 2. This, of course, is a negative number. But this is also a negative number, so negative divided by negative will be a positive. And the sum is going to equal, if you punch in your calculator, 1,275. Now, there are 2 important words you need to know for the next piece of the video: diverge and converge. This is a series that diverges because it's getting bigger and bigger and bigger and bigger and bigger and bigger and infinitely big. It's diverging. This one over here, the first one, on the other hand, is converging, and it's converging to 0. Because it's getting smaller and smaller and smaller and smaller and smaller. So the sequence itself converges to 0, and the sum of the series is converging to like 5.714. This one, on the other hand, both the sequence and the series are diverging by getting bigger and bigger and bigger and bigger. All right, we have a few more examples, but I'll do that in a second part because I don't want this to be too long. See you soon.